Hi, my name is Charlotte Cooner. This is Solving Everyday Ordinary Problems with Calculus Extras video explaining the Calculus T problem. So, I'm going to be explaining all the math and all the calculus behind the other video, and this video consequently is going to be more boring. If you want to see the more exciting video, there's going to be a link in the description for the original video. This is just explaining everything. Okay, so first of all, I'm going to explain a bit about derivatives. I'm not going to worry too much about explaining the definition of a derivative. Right now, I'm going to explain what that means in terms of math, in terms of the equation that we're using and how to solve what's called the differential equation. Now, simply put, a derivative measures the rate of change. So when you take the derivative of something, there's a whole new equation called the derivative. And if you want to go backwards from the equation called the derivative back to the original equation, the process of going backwards is called integration. Taking the derivative is exactly the opposite of taking the integral. The way you write a derivative would be dy dx. Most of the time you see that. I don't know if you can read it. It says dy dx when x is the independent variable. So the way you write an integral looks like this little s. So if you have a function, we're going to sort of say f of x. So the integral of f of x, let's call that big F of x. If you take dy dx of big F of x, you get back to the little f. So this just kind of shows that they go opposite directions from each other. And this is how you write an integral, and this is how we're going to be writing a derivative. Now, a differential equation would be written like this. If you're given this and you're asked to find the original equation, that's called a differential equation. The way we do that is we treat this dy dx like a fraction. So we treat dx and dy as these two separate pieces, and we get dy with the part of the equation that has y in it, with only y variables, so that we can then differentiate the y variables separately from the x variables on the other side. Now, I know that sounds really complicated. In this example, it's actually quite simple. We're going to start with Newton's law of cooling as it is given in the problem, which is actually a differential equation. So it starts off dy dt equals k times y minus m. I'm going to do a little cross multiplying here, multiply both sides by dt, and at the same time divide both sides by y minus m. So dy over y minus m equals k dt. Now, I am going to take the integral of both sides to get rid of these dy's and dt's and get back to the original equation. Now, 1 over y minus m falls under the 1 over x category here. So the integral of 1 over x is natural log of x plus c. We're going to do that. So we have, and this whole thing counts as x. So natural log of y minus m. On the other side of the equals sign, we have k times dt. K is a constant, so it falls under this one right here. So the integral of a constant is a constant times the independent variable, which in this case is t, so we have kt. Now, plus c. That's the constant for both of these. We don't need two constants. They can be the same constant. Okay. So now we want to get rid of this natural log over here because y we want to get y by itself. So we take e to the both sides because e to the natural logarithm of x, as you see over here, e to the natural log of x is just x. That's one of the properties of logarithms. So we take e to this natural log of y minus m, and then also e to the kt plus c, we get y minus m equals e to the kt plus c. Now we just want to get y by itself, so we add m to both sides. Y equals e to the kt plus c plus m. Now it might seem like we're done, but in truth we have two constants here, and we need to solve for those. So first of all, we need to get rid of this c. Now if we go back to the properties of logarithms, we see that e to the x plus c equals e to the x times e to the c. Here we have e to the kt plus c, which is equal to e to the kt times e to the c plus m. So e to the c is really just another constant. So we're going to call this c2. Y equals c2 times e to the kt plus m. Now we have to figure out what the c2 is, and we don't have to use any data to figure it out. We just have to use the equation. Y of 0 equals, now this y of 0 means time equals 0, t equals 0. So if we have e to the kt, if t is 0, 0 times k is also going to be 0. E to the 0 is 1, just like any number to the 0 is 1. 1 to the 0 is 1, 15 to the 0 is 1. That's actually written up here, right there. So, this whole thing is 1. So we have c2 times 1 plus m. Now we're trying to solve for c2 so we can get the c out of this whole equation. So, subtract m from both sides, and I'm just going to write c2. Subtracting m, y of the 0 minus m. So now we can go all the way back up here and plug this in for c2. So plugging this in up here. Alright? Y equals y of 0 minus m times e to the kt plus m. Does it look familiar? If you watch my other video, it will, because this is the equation we use. Now, since